Pete. I will get the
Right.
screen going.
And I started the recording this week, so we'll be able to put it up on YouTube.
Okay.
Sorry to
So I'll
everybody.
share my. So my screen should be up now. Is that correct?
Yep.
Okay. I'm going to put this to the side. Welcome everybody to our weekly weather discussion. We're really glad people are tuning in during the great hiatus here and enjoying our discussions. And I think if we could, I think it's easier to stay passive when you're on electronic media. So if you could, increase the interaction, that certainly will not upset the discussants. If those of you who have come to our, actual face-to-face on Fridays realize they become sort of a intellectual rumble, and that's perfectly okay to try and mimic electronically. I have no problem with that. I know Michael doesn't. I know Greg doesn't. I know Pete doesn't. So anybody who's got a comment, find a way to get our attention. Keep talking over us, even though we're all trained and to not be rude. That's the only way to do it with electronic stuff. So go right ahead and do that. So I'm going to start today with the satellite movie for the last 12 hours, I think it is, over the continental United States and adjacent waters. It's about 10 hours. A really quickly moving cloud system that you can see racing across from the Missouri-Iowa border in the beginning of the movie to already the Pennsylvania-New York state border. So this thing is roaring to the east. We'll see why when we go to the upper level charts. But that was a fairly interesting little weather system that dropped some snow, still is dropping snow apparently in the southern part of our own state. Janesville and Rockford still have snow. Chicago had some snow this morning. Detroit had moderate snow for a period of time. And I think Kenosha had maybe enough to dust the grass. And so, pretty interesting that we've had now, I think, 3 straight Aprils with snow after the 15th of April in the region. And there had been a number of such Aprils where that hadn't happened for quite some time, as far as I can recall. I know it's not unprecedented and really not that unusual, but we tend to go in streaks is what I'm getting at, is that some Aprils you'll go 4 or 5 straight Aprils without any of that mid-April snow, and then all of a sudden we've gotten 3 years in a row where we've had some snow. And of course, Tuesday was a really exciting day this week with non-stop snow squalls from, I don't know, probably from about noontime or maybe even earlier, all the way through to almost sunset. So, and as in contrast to the ones that Matt Hitchman talked about last week, that really did take on some larger than individual cell organization, the ones on Tuesday struck me. I had my eye open for it. It's funny, how that works. Matt had given such a good discussion of what we saw the week before, that when the snow squalls started popping up, I thought, okay, I'm going to kind of babysit this and see what sort of structures emerge. And to my eye, nothing really. It was very much open cellular convection right underneath, this time at 850 millibar cold pool. The cold air had gotten a lot lower, and so the stratification was even weaker on Tuesday. And so we had nearly dry adiabatic lapse rates, maybe even super adiabatic at one point or another, at one location or another. So it was a really great day of snow squalls. And at one time, certainly we had moderate snow in my house and maybe in other places around the area. So what we can see on this infrared satellite image, besides the weather system that's just tracked to us and kept us without, I think, any snow today, is this is probably not cloudiness up here in Quebec. I'm not sure. I haven't looked at all of the different satellite movies to be sure of that. But I wouldn't be surprised if this is just cold air. And you'll see when we look at a hemispheric map of 850 later on in the discussion, we really have just a spine of really intense cold air that's going both from the western to the eastern hemisphere. It's worse in the western hemisphere. And the worst place to be right now, if you want to be away from winter, is the northern plains of the United States and the prairies and central provinces of Canada. So that's us. And we've had a pretty cold second part of the first half of April. First week wasn't so bad, but it's been pretty chilly from about the 6th or 7th on. And that doesn't seem to be immediately to be dissipated, at least probably through the mid part of the coming week, it looks like to me, maybe even later than that. Okay, so, go ahead.
Scott Lindstrom just had remarked in the comments that about the size of the cyclonic gyre around northern Hudson Bay, that it basically covers the entire GOES footprint.
Yeah, it's gigantic, is right. We'll see that when we go to the super Pete at 500 millibars. That's a very good point. This is a gigantic piece of wintertime Arctic air that is the center of this polar circulation maxima, the minimum in geopotential at 500 millibars. It's going to gradually wither away, but it's taking its time, and it's organic is right, absolutely right about that. Okay, so the only other feature on this map for right now I want to point out is another cyclonic disturbance over Southern California. Last week it lasted the entire week, the entire work week. Monday through Friday it was raining in Manhattan Beach and other places in California all week long. This one, I'm not sure if it's actually raining. We'll see on the radar. I think there's a little bit of rain just north of the Bight, but it's a second straight period with an upper level low, and there's one that's further offshore that we'll see, I think, in the West Coast satellite image when we get there. So, yeah.
So one of the interesting things about that cutoff, and we'll see it when we look at the superpeat maps and other evidence, is that because there are these parade of cyclonic disturbances in the eastern Pacific, the one that's over California is not going to be as cut off or as long-lived in one place, as stationary for that long. So we'll see that.
Oh, yeah. Yeah, and we talked about it a little bit last week with respect to the one that migrated slowly and elongated across the central part of the country, responsible for 36 deaths with the tornado outbreak over the weekend in Arkansas, Alabama, Mississippi area. And it's always been a troubling forecast issue. How do those things eject, and what shape do they take when they do? I'm not sure we've made as much progress on that problem as we have on other ones in numerical weather prediction, which is a curious question. Nonetheless, it seems to be true. So let's go next.
As long as you're talking about previous weather here, maybe Pete can show that movie of the Kelvin wave from Tuesday. Do you have that anywhere, Pete?
I do. Hang on one second. I got to download it.
The Kelvin Helmholtz wave, you mean?
No, it was a coastal Kelvin wave off of coast of Washington.
Oh, I didn't know about that. Okay. Pete, do I have to relinquish control, or can you just take it over?
You'll have to relinquish control. Hang on one second. I'm downloading it.
Yeah. Fat chance, Pete.
Yeah, you're hilarious.
Okay, I'm going to do that now. Should I do that now?
Sure.
Okay.
Let's see. Okay, so here's one of them. I gotta share
I think the second one that you sent me was
the more close-up one.
Yeah.
Okay. I think that's this one. Are you able to see that?
Oh yeah, that's nice.
This is what the feature that they were talking about.
That's like a marine push, but comes from the north instead of from the south.
Yeah, well, the Coriolis pushes it. It's like the ones.
No, wait a minute. The Coriolis force should be.
No, that's right. You're right. The Coriolis will go the other way. Yeah.
Yeah.
Maybe that's not a coastal. Maybe I'm identifying that wrong. I wonder.
It looks like one, though, but yeah, it can't have the basic dynamics of being turned into inland. But
yeah, but it is going straight down the coast like that. Yeah.
Yeah.
Want to see the farther up view on that? There's
I think you're right, John. I think I'm wrong on that. I think that's not.
There's the farther out view that we were looking at when you first thought that's what it was.
That is so interesting. I've never seen that kind of a north invasion from the northwest up there. Who else is it? Is Angela here? Or too bad. I don't see Angela or Liz. Sometimes they know about these things in the northwest too. Yeah, that's certainly not got the Coriolis force in its favor. That's for sure.
Yeah, that's right. So it can't be really trapped on the coast, but yeah, no. Then I don't know what it is. It's just mysterious.
That's even more interesting then.
Yeah.
Yeah, it doesn't have an obvious explanation. That's fascinating. Wow.
All right, back to you, John.
Okay, I'm going to go back, and I always have to hit it twice. I'm not sure why that is, but it should come back now. Okay, so we're back, I think, right? Should see the radar summary.
Yep, all good.
Oh, okay, so here's the radar summary over the continental United States this morning, ending at about 11 p.m. And, sometimes it's really easy to see the distinction between where the precipitation's falling most likely as liquid and where it's falling as snow. And here's a really good example. You can see the higher reflectivities in central Ohio to southern Illinois, southern Indiana, racing eastward, and then much lesser reflectivities grazing southern Wisconsin and then going across to southern Michigan. We'll see in a minute that there's a period at least of moderate snow at Detroit, and then some lake effect precipitation. I'm not sure it's snow. It probably is. It's certainly cold enough up over the Tug Hill Plateau and in the Syracuse area, and then some light precipitation just south of San Francisco Bay, north of the Bight, maybe in the valley, in the far southwestern part of the valley of California, and then some interesting banded structures in the reflectivity off the Oregon coast. I'm not sure really what to say about that. It's kind of curious, and there's not a lot more information on that. And then this might be some of that cold air that was over us, or at least behaving the same way over the state of Maine that we had on Tuesday. These are undoubtedly snow squalls and otherwise partly cloudy conditions, heating the ground up, the stability's low, and there's enough water from prior events on the ground that doesn't matter that it's a dry land. It's really not. There's plenty of evaporation going on there to fuel those interesting spring snow showers. Okay, so that's it. I mean, this is really the only game in town at the moment across the continental U.S., but it's hitting one of the major airports in the country in Detroit, and it's kind of moved its way through St. Louis, and it's on its way now to Columbus, Ohio. So let's take a look at the surface map before we go to upper level charts. And I took one from an hour before when I was getting ready. So this is, I think, the 10 a.m. surface analysis. And I did it because there were isobars on it. That might be a useful thing to try and understand what some of the basic structures here of this event. So I'm going down to Illinois and Missouri first, and you can see that's where the elongated pressure, trough of low pressure is. We've got pressures around 1,015 millibars, a little bit on the less than 1,015 here on the Illinois-Indiana border near Terre Haute. And then to the south, it's warm, 50s and so on, 49 in St. Louis, 56 at further south, and 65 just to across the river from Cape Girardeau. So pretty warm temperatures to the south, and dew points are modest. It's really not a warm, moist air mass. 61 over 36 at Lexington is not really a wild dew point, or Bowling Green maybe. And then over the state of Wisconsin, interesting, light snow in Milwaukee at the time. There was light snow at Rockford, light snow at Chicago, moderate snow at Detroit, moderate snow further to the, that's Detroit, I guess. This might be Ann Arbor. So right. There's a region of moderate snow in southeast Michigan, light snow at Grand Rapids, and then light snow here to the northwest of Fort Wayne. What is that? Gary, Indiana. And this Fort Wayne has moderate snow. So kind of interesting region of central Great Lakes, heavy, moderate snow this morning with this really weak sea level pressure minimum.
Excuse me, John.
Then, yes.
I was just going to note an interesting aspect of the structure of the cyclone, and we'll see it somewhat, the evolution of this borne out in the forecast. But if you recall in the satellite imagery that you were showing, there was a nice baroclinic leaf cloud that was over Michigan and Ohio and areas downstream of that. And the surface cyclone, at least at this point in the analysis, was over central or maybe even northeastern Illinois at this point on the map that you're showing now. So there's there's a large disconnect between where the cloud head is, where the lower tropospheric precipitation is, and as we'll see when we get to the superpeats, the upper trough is even further to the west of this. And it's going to be interesting to see the evolution of all these coming together to a much more impressive cyclone off the East Coast in about 24 hours.
Yeah, that's a really good point. I hadn't looked into the future on this one. This disjuncture in structure is really quite interesting because it doesn't seem to me in this case that it has a substantial orographic component to that disjuncture, which sometimes it does. This is just a really interesting place where the cloud head and the moderate precipitation is way out ahead of the sea level pressure minimum, as you're pointing out. It's a really good point. And we'll see, and it's way ahead of the 500 millibar trough too, which is very interesting. That's over the Kansas-Nebraska border pretty much, which is well to the west. So that's a very good point, which we'll investigate a little further. When we go down to the southern states, pretty nice day in Atlanta, 45 dew point. Anytime you can get a 45 dew point in Atlanta, you're probably pretty happy about that, especially if it's in April, May, June through November, probably the way it's been. And then the peninsula is the only place with really high dew points down in Florida. It's not even so bad in New Orleans with 62, although that's past my limit for guaranteeing comfort, but Little Rock at 47 isn't. And then in much of the state of Texas, except for the coast, the dew points are moderate. Dallas maybe is the leading edge of the really moist air, and then it goes all the way across to, is this Del Rio down here on the river? So the southeastern third of Texas is pretty warm and moist. Everywhere else, considerably drier and much colder. Look at these temperatures at like Amarillo and Lubbock, and in the mid 30s. So that's cold. And there's a nose of high pressure coming down, as is often the case in the immediate lee of the Rockies when these cold, dense air masses funnel their way southward. Might have been interesting earlier today, or maybe even yesterday, to look at, before this thing developed over the Central Plains states, to look at some of the mesonet time series in Oklahoma, because I'm sure there was some rapid temperature drops during the day. Sorry, I don't want to give you vertigo here by moving quickly, but we'll go to the Pacific Northwest. Temperatures are probably about seasonable for the year, for this time of year, I should say. Dew points and temperatures are about the same, so kind of cloudy, not so nice down there. And then no single station that we have at this density is reporting rain, although I think the radar, I'll show you in a minute, will indicate that there's probably some at least falling somewhere, but maybe not getting all the way to the ground. Okay, so let's go to, where did I have my, I already looked at the radar. We already saw that. So let's go to the 500 millibar map next. And this is from this morning at 7 a.m. And so as Michael points out, don't forget, this is the region, really southern Michigan, Indiana, parts of northwestern Ohio is where it's snowing rather moderately. And that's well downstream of the upper level trough axis. However, it's not that far downstream from a region of decent confluence. So there might be some mid-tropospheric confluent frontogenesis. The baroclinic zone here is not insubstantial. It's minus 19 at Champaign-Urbana, minus 19 near Kansas City, and then you're into the minus 30th range in northwest Iowa. And so that's a pretty decent mid-tropospheric temperature contrast with a little bit of confluent flow on top of it. Certainly enough perhaps to produce the ascent in about this region on the warm side. It looks better at 850 actually than it does at 500. But very cold air in the midst of, in the axis of this trough. We're minus 30 or colder over Minnesota and eastern South Dakota. That's pretty cold for early April. And there you go. And there's the upper cutoff, as Michael pointed out, nowhere near as isolated from the rest of the flow as what we saw last week. And there it is churning away fairly weakly compared to last week's north of the Bight of California. A lot of baroclinicity, though, across the broad westerly flow over the North Atlantic all the way into the central part of the United States. There's more baroclinicity here over northwestern Hudson Bay. I think that's a factor that will keep us likely to be on the colder than climatology side rather than warmer than over the next several days. But this might be the last chance that the flow gets. And as to emphasize Scott's original point of how widespread this giant vortex is centered to the north of Hudson Bay, it pretty much takes over the entire country of Canada, with the exception of the western mountainous provinces and maybe the western Arctic provinces, which are just on the eastern side of a ridge that has flow coming right off the north slope down to North Platte, Nebraska. So this is probably a very anomalous upper level flow. I don't tend to look at finding the anomalies and highlighting how intensely anomalous it is, but I wouldn't be surprised if it's quite anomalous right now. So 300 millibars, kind of a convoluted looking upper level structure at 300 millibars. It does appear that there's some sense of a jet core down over the Carolinas and northern Georgia and Alabama. That seems separate from the jet core that's over the southern Great Lakes and then trailing back towards the Denver area through Nebraska. So my initial guess here is that we have some sort of a polar jet, subtropical jet and this fishtail structure here makes me really feel good about that initial at a glance diagnosis. And I'm going to look at a cross section in a minute that will give us some evidence for a near proximity of these two jets, but they're clearly quite separate. And the weather system with the precipitation is here in the left, no, the right jet entrance region of this little jet streak that's over, Lake Erie and parts of eastern Michigan. So pretty intense into a long flow range, and that might also be a factor that's helping to produce an upper divergence maxima in the region where we saw that cloud head. And it's not really so well connected as it turns out, perhaps to the upper trough axis. So that's an interesting aspect of this structure as well. I want to go to 200 to see if we can see a separation between these two features. They look a little bit amalgamated at 300 millibars. And indeed, it doesn't look like there's any clear separation except when you get farther off the Pacific coast. There's a clear subtropical jet on the southern periphery of this whole structure. But what's going on further north than the core of that subtropical jet, which runs through the Carolinas into Tennessee, is hard to say. So I'm going to look at a cross section in just a second. But 170 knots at Nashville at 200 millibars, that's a pretty strong feature. And it has a connection to flows nearly as strong, 120 knots, well off the coast of the Baja California, and then all the way up to the south and east of the maritime provinces of Canada. So this is the southern edge of that deep vortex that Scott drew our attention to before looking at these maps. And then at 850, there's really nice baroclinicity back through Oklahoma, the panhandle of Texas area. This is just the cold air that's funneling down, being trapped by the mountains as it turns to the right. And then the eastern side is just piles up fairly strong temperature gradients, fairly shallow. I don't think you'd see them this strongly at 700 millibars. But all of this baroclinicity, even though it's frontogenetic, look at the wind shift between Kansas City and Monette, Missouri. It's 90 degrees across a strong temperature contrast. It's not the only place where things like that are happening, further west in Kansas into Oklahoma City. This whole region strongly frontogenetic at 850, but it's fairly absent of clouds or precipitation, which we know the precipitation is concentrated over southern Michigan. That's also a region of strong frontogenesis, 35 knots near Cincinnati, racing into air that's hardly moving out of the way and much colder, and so that's intense low-level frontogenesis, which is a factor, I'm sure, in producing the cloud head and the precipitation in that region. But this frontogenetic activity, not calculated but apparent from the winds and the isotherms, seems to me to be pretty strong, but it's not doing anything in terms of generating substantial cloudiness or precipitation, even though on the warm side, the dew point depression is only 1 at Oklahoma City, so that's reasonably moist air. It's 10 over 2 at Dallas, so that's a 2-degree dew point depression. Can't read what it is at Monette. It's very dry at Little Rock, so there's a patch at least of relatively moist air on the warm side, which one might expect is being forced to rise, but nothing's really showing up from that. That's interesting.
John,
I guess, yeah.
I was going to just speculate that perhaps it's significant stratification that might be not allowing the air to rise as rapidly as you might.
That's possible. That's possible. I was just going to say that the way to get at the core of that question would be to look at different levels, maybe some soundings, and really see what's going on here, because you can have forcing that's strong, but it's got to overcome the inhibition that's a result of the stratification in a frontal zone. So that could well be the case. That's a good point. Okay, I think I only had 2 things left to do, and one is I want to take a cross section. I want to remind you what was interesting about this 300 millibar map. I was thinking I wanted to see what it looked like if we cut all the way through all of this interesting wind speed maxima near the tropopause, and then along that same line, I don't know how I did that, so sorry. Along that same line, that line will be cutting right through the subtropical jet core at this time. So let's go to tropical tidbits. This is a forecast. It's not quite the same time as the analyses we were just looking at, but it's a forecast valid at noontime, so valid right about now. So I'm going to cut a cross section right along through Lake Michigan to kind of perpendicular to this wind speed maxima, and then as best I can through the one further to the south. So let's see what this really looks like. Something like that is what I'm hoping to capture, and then we'll take a look at the potential vorticity, and that'll give us isotropes as well as some isotachs. So right along that line through that amalgamated jet, one really does see 2 separate jet cores, one of them about 280 millibars, and that's associated with this pretty decent middle tropospheric upper front. Doesn't really get down past 500 millibars in any sort of intensity. But the horizontal shear is very strong, the vertical shear is very strong, and then the dry adiabats every 5 degrees are in green. So you get a pretty decent upper front there. And that's right about south of us where we have, the cloud mass racing to the east. So one imagines this pendant of PV, which is manifest as a vorticity maxima, perhaps at 450 millibars, is being advected down shear to the north and east, and that might be another part of the forcing that's driving the ascent there. And then further to the south over sort of the Tennessee, Kentucky border, you have a subtropical jet residing around 200 millibars, very much shallower baroclinicity underneath it, Very shallow horizontal shear. It's really confined to the 140 and the 130 isotac. There's not much else besides there. And then the vertical shear is confined around 325 Kelvin. So two separate jets, no chance at all that they're really kind of acting together. I think the subtropical jet is a lot less dynamically potent in this instance along this section than the one from the polar jet. So that's my sense about that. And then just one last thing I wanted to show is the 850 millibar. I think it's the analysis. Let's check. Yeah, the analysis from this morning over the hemisphere. So to get yourself situated, here's the United States, as you can see, in Canada to the north. This is it. This is the spine of cold air. I mean, if you look at the distribution of really cold air at 850 all winter long, this two centroids connected by some sort of connecting region of cold air. It's all over continental, except for the pole. There's a continental component over Siberia, Mongolia, and there's a continental component over central Canada and the northeast United States sometimes, but this is all in Canada. That is the region that stays cold for the longest, and this is going to start to evaporate quickly at this time of year. We're not going to see many more days with temperatures in the minus 22 to 24 range at 850 in this region where the bloody red cold is right now. And it's there'll be, and I don't know how it's going to actually go down, of course, which one of these pools will evaporate first. My guess, given the size, will be the Mongolian Siberian one disappears before the one that's over most of Canada in the archipelago. It could well happen differently, but given our general flow and the general proximity to this cold pool, we are bound to be visited by, I think, looks like at least one more of these incursions. Maybe not as intensely as this week, but it looks like Monday night into Tuesday is another chance where we get into the sort of pinkish cold air. That might be the last one of the year, because when you look at the medium range out to 8 days, the size of this cold pool at these temperatures really shrinks by the time you get to the end of that period. Perhaps a faster shrinkage than any other time of the year. So that might mean that it's finally evaporating away. Evaporating is used colloquially. So we're not out of the woods yet, but we're getting close. That's my sense at the end of the discussion. So I'm all done. Margaret, if you'd like to make an announcement about the 102 class, that would be great. And unless there are any questions or comments. Okay, I will relinquish control.
All right, thanks, John. Hi, everyone. Summer will happen eventually, and when it does, AOS has an online climate change course, and we need 2 TAs to help teach that. Usually I walk around the building and talk to people, but I can't do this time. So last year, Andrew did it, Andrew in April, and it's a super rewarding experience. I think it's mainly for non-majors, and it's quite rewarding to interact with them on their thoughts on this important topic. The main job is grading and also interacting via the discussion, the chat that goes on every week. They're required to comment on discussion topics. So if you're interested or available, please send me an email, with a few sentences about why you want to do it, and ideally your CV. And if any undergrad has taken the class and gotten a high grade, you'd be eligible to do that too. So thanks for the airtime.
Thank you,
Margaret.
Okay, so we'll go now to our forecast part of our discussion. Take me a moment to bring this up. Just a second. Sorry, I had to switch viewers today. Let's see if this comes up. Do you see an analysis scrolling by?
Yep, looks good.
Yes.
Okay, so not analysis, the forecast, yes? Okay.
That's correct.
Okay. So, yeah, good morning, everyone. We're going to look at the forecast for today, or for the short term. We'll start off always with our meteorogram, and you can see a pretty nice weekend in terms of temperatures as expected. This is, again, an MM5 forecast. It's at a relatively modest resolution of 90 kilometers. We'll see some a newly developed configuration of the WRF model next Friday, Weather Watch. Isaac Slusi, undergraduate freshman, has been working with me in developing a real-time run of the WRF model. We'll begin to see some of the output from that next weekend, or next Weather Watch. But for this Weather Watch, we're looking at temperatures over the weekend, tomorrow being probably the warmest day of the two coming up. Also, we'll see the dew points increasing as well as the flow turns to the south. And if we look at the precipitation forecast at the very bottom of this panel, you'll see pretty much a dry weekend until perhaps we get to a Sunday late morning into the afternoon when a little bit of precipitation is anticipated. You'll also notice that Sunday is going to be perhaps the cooler of the two weekend days, with temperatures perhaps around 50 or so, whereas tomorrow we may actually get into the low 60s. And that's confirmed by some of the EFS MOS products. If we next turn to the time height section, this is out through 60 hours, we see a couple of really interesting features. Again, just to reorient ourselves on this map, and I'll try to make it so that you can see a little bit more of the map, or not the map, but the chart. The legend is yellow are the isentropes, lines of constant potential temperature. The blue contours, solid blue, are ascending motions, that's minus omega that's plotted. Subsiding motions are the dashed lines. And the red lines are relative humidity of 70%, contoured every 10%. So the first thing to note, is there a question? Can't capture that.
No, I think Scott was just pointing out that what the model seems to suggest for the weekend is about right on normal. Normal high is 59, normal low is 37.
Okay, wow. So it's going to be so warm. It's been so chilly recently, it's not going to seem like normal. And maybe when we end up, Pete could just show the statistics that Ed Hopkins has updated. That'll be kind of a nice way to wrap things up. Because knowing what normal is in these days and age, this day and age, is a little bit weird. So getting back to the weather, one of the curious things and the most conspicuous things that you see on the map is the dip in the tropopause. You can see that's the green line, the 1.5 potential vorticity surface that marks the dynamical tropopause. And you can see it reaches a minimum over us in terms of its elevation at about 450 hectopascals, which is almost pretty close to what John was seeing when he did the cross-section earlier through the jet. So the edge of that jet and the sort of appended upper trough that's associated with it is going to pass over our area, the minimum of the trough, later this afternoon, and that'll mark a period of increasing descent over us and subsidence over us with time. You'll also notice that the isentropes are bowed upward underneath that upper trough, so it's kind of a nice classic configuration of an upper trough. If you do a cross-section through an upper trough, but we're looking at a time height section as this upper trough passes by.
You can see him bowed down in the stratosphere even.
Yep. Yeah,
really
so it's
nice.
Warm above, cold beneath. And then you can see flanking it in terms of vertical motion patterns, the pattern of ascent that we briefly passed through earlier this morning as the upper trough began to approach us, and the descent that's expected later tonight into tomorrow morning. So a really nice sort of classic upper trough pattern. And you can also see the atmosphere drying out as not drying out, but the relative humidity is beginning to decrease as well. With some sun in the afternoon, we develop a well-mixed layer. So mid-afternoon, you can see potential temperatures are almost uniform with height. By the time we get to 0Z this evening, 7 p.m., you can see the winds are also fairly constant, 15 knots out of the west. And the potential temperature is also uniform. So a nice well-mixed layer that goes all the way up to about 2.5 kilometers in depth over us by later this afternoon, early evening. We cool off tonight, and you can see the formation of a stable layer, and then you can also begin to see evidence of the winds beginning to veer strongly or veer somewhat with height, and that's indicative of a geostrophic warm advection pattern, and we begin to warm up. You can see the isentropes beginning to descend, which indicates that's warming temperatures over us, and between today and tomorrow, we're supposed to see our potential temperatures aloft go up by about 6 degrees Celsius. And so tomorrow will be certainly a much warmer day than it is today as we mix out during the afternoon with a brisk wind out of the southwest at 25 to 30 knots or so. So a pretty breezy day above us at the surface. The actual surface winds will probably be somewhat muted, but this is just the raw model output interpolated to isobaric coordinates. Then tomorrow evening, the winds continue out of the southwest. We begin to cool off again, but we also see clouds beginning to encroach over us. The relative humidity begins to increase and ascent begins to occur. It's not the encroachment of an upper trough, but we'll see it's actually a front is going to begin to approach us. You can see the winds going from southwesterly to more westerly near the surface, and then turning abruptly to the north Sunday after late morning, early afternoon. And with that, the arrival of some chillier temperatures and maybe some post-frontal precipitation. And we'll get a chance to look at that in a moment. Notice the relative humidities go up. We have strong, modest ascent over us. I think there's 3 microbars per second. So it's pretty good, and the column's getting saturated, and that's consistent with the arrival of the precipitation. So what's happening? One thing I want to look at is, I'd mentioned this earlier, I'll first just do a loop so you can get a sense of the progression of some of the features across the country. We'll first look at the cyclone that John was looking at that produced some of the snow to our south earlier this morning into the late morning, and then it's now producing precipitation over Indiana and Michigan. We'll see how that evolves, and then we'll look at the weather over us. So this loop is rather fast. It'll start up again, but you can see the progression of this cyclone to our south that scoots across the northern Great Lakes. I should really just download this so you can, I won't download it, I'll just start off at 6 hours in the forecast. 1,014 millibar or hectopascal cyclone located in just northeast of Indianapolis. In the forecast, you can see the accumulated precipitation over the 6 hours ending at this period. And that kind of maps out well what we saw in the radar and some of the individual observation reports. Go ahead 6 more hours. Cyclone doesn't deepen too much. It's at 1,011 as it moves into, it's approaching Youngstown, Ohio at that point, and you can see the strip of precipitation associated with it. You can see our winds turning more out of, if you look back over southern Wisconsin, fairly light winds out of the west-northwest, at least the geostrophic winds are. But as we emerge later tonight, the cyclone really begins to deepen. It's now at 1,000 and I think that's about 1,009 hectopascals. So, and the moderate precipitation forecast over the state of Pennsylvania into southwestern Massachusetts. And then stepping ahead, this is now at 1,005, so the deepening is really beginning. And so one of the things I was interested in is just, why do we see this sort of delayed development of the cyclone? And one piece of evidence I'll point to, it's indirect. We really want to go through the business of tearing apart the potential vorticity associated with this. But if you go back to the initialization of the model, this is the 12Z in the model forecast. Again, we saw that cycle. You see a cyclonic circulation that's well back over parts of northeastern Missouri this morning at 850 hectopascal, and you see this broad area of warm advection to the east. And I think we were trying to look at the factors that were contributing to the precipitation. We saw a number of things that were contributing to that. One of them was the entrance region to that little jetlet that was over Michigan. But I also think, I'll get John's and Greg's suggestion in this, we also have, it looks like a region of localized warm advection as well over parts of Indiana and Illinois. I'm wondering if that's also this localized, strong, concentrated region of warm advection. And that warm advection does weaken as you go toward the colder air, so it's also frontogenetical. But it's lower tropospheric forcing also contributing to that precipitation.
Yeah, I think that's absolutely right. That there's no question that's the case. We even saw it on the 850 analyses
Right.
that it looked like there was some frontogenetic differential warm advection going on there. I hadn't thought about the local maxima for a long isentrope Q vector, but that could also be a factor, yeah.
Right, and so you go ahead another 6 hours, you see that cyclonic disturbance kind of jumps rapidly eastward, but you see this almost jet-like feature across parts of Ohio, this little maximum warm advection that's spreading the precipitation further to the east in the forecast. But you'll see that the cyclonic circulation here at 850 hectopascals is to the west of where the thermal ridge is, and that thermal ridge is in part created by the fact that some of this warm advection is impinging on the west sides of the Appalachian Mountains. But you have this local warm anomaly that's being created at 850 millibars over the Ohio Valley. The upper trough is still well to the west, and so the surface cyclone is kind of somewhere in between. But we'll see over time the structure of the upper trough at 500 millibars becomes better associated with the storm. Here it's very kind of strung out west to east in the vorticity pattern at 500 millibars. I'm going to jump ahead just because of time, but we'll go to 12 hours in the forecast. It's a little bit more concentrated. It still has a west-southwest to east-northeast tilt. Then look at how the structure changes. The structure is a little bit more more southwesterly in its tilt, so less of that west-southwest tilt. Get to 36 hours, you see the tilts continuing to decrease. And it's over this time period as the structure of the upper trough becomes more favorable downstream of it for advections of vorticity that we begin to see the increased deepening rate. And so this might also be, John, just as a throwaway, this might be an interesting, not a very significant case, but you can see the structure of that upper trough changing its structure. And that's kind of related to some of the work that we've been doing, looking at how the upper trough evolution impacts the deepening rate of the cyclone. This might be an interesting case to look at.
The thing that catches my eye is, I'm sure it would show up in another way to measure this, is that you get a deep tropopause trench being built there, maybe even more dramatically than the orientation of the feature is changing. So it's kind of a linear feature for a long period, but it doesn't deepen.
Right.
You're not ushering stratospheric air downward until a certain point in that evolution that you pointed out, and that makes a big difference. So yeah, that's another great case. You're right. It's another one we could really have some fun with.
So here's the structure of the trough. This is the potential vorticity field. Again, you have this upper trough that just kind of lazily goes across the country. Its tilt slowly changes, and unfortunately, it's until the very end you can see it really begins to ball up rapidly.
Yeah.
Associated with the cyclogenesis event. But and again, you can see the deepening. You can really see lots of precipitation associated. It gets below 992 once it gets offshore. So this is a pretty interesting event, but it deepens well off the period, well beyond the period that we're kind of focusing on. But coming closer to home, so by tomorrow morning over the central, the upper Midwest, a broad geostrophic west-southwesterly warm advection spreading across that region. Again, we see the trough is already to our east. We're in a warm advection pattern. By 30 hours into the forecast, that warm advection continues. That's a brisk southwesterly flow that sets up. We see some of that cold air in central Canada that's just to our north, about to enter to invade from the north. To 36 hours in the forecast, this is 850 millibars. Again, that strong warm advection, 45 knot winds over a central part of the state out of the west-southwest. We're just sort of bringing that nose of warm air over us. And again, with this sort of localized warm advection, there may be some, even though it's not, we have to look at the air is relatively dry, but we probably have some very weak ascent associated with that.
Yeah, I would think so too. And if all you did was look at the sea level isobars and the 1,500 thicknesses at the same time, you would have said it's uniform warm advection. So I don't see how you're going to get ascent, but you go to another level and sure enough, there's more of a nose, and that makes a difference. Yeah, it's really interesting.
That's an interesting setup. And so dry air, even if we do have some ascent, is probably not going to cause much in the way of cloudiness. So 36 hours in the forecast at the surface, you can see that strong warm advection, and we're in a nice thermal ridge pattern. But there is a cold front that you can see that's made its way through the northern third of our state into just south of Minneapolis. You can see the winds turning, but the surface trough is there. So that's the beginning of a cold front arriving. We'll look at a closer detail of the high resolution grid. You can see the front makes its way to the south, and all the precipitation, curiously enough, is on the north side of this front. It's made it through the 2/3 of our state by the time we reach Sunday morning. And it's late, it's during Sunday afternoon. Let's go to Sunday morning. Surface map. Here's our surface map from the 30-kilometer grid. You can see we're still with west-southwesterly winds over us. The cold advection is clear to our north, and sort of a broken area of precipitation is forecast by this particular model forecast. I'll say other models are generally dry at this point.
It's really interesting. I mean, you don't see post-frontal. This is clearly post-frontal precipitation in the forecast model over the continent very often. I can't remember it ever happening in Madison.
Yeah,
it's common in Seattle, but not here. It's very interesting.
Right, but I guess I should be very careful, and that's my apology on this, because I guess as I'm saying that, since this is the accumulated precipitation through 3 hours ending at this time, some of this could have been just before the front passed through.
It would have to be a fast-moving front. In either case, the weather's going to be dramatic Sunday morning, it looks like.
Yeah, so 3 hours. This is now 10 a.m. We're still westerly. The front, maybe Greg is going to be reporting the frontal passage before we do here in Madison.
He will, for sure. There's no doubt.
Left of us, but east of Madison, the winds are still out of the west, and just north of Madison and to the northwest, we see the northerly winds. But yeah, that precipitation actually still stuck out there. So this is definitely post frontal. And
Wow.
then by the time, this is kind of interesting, we'll just have to watch how this develops. Just a burst of precipitation over us by this time. I mean, definitely frontogenetical in the circulation. We'll look at the water vapor content, so there may be a frontogenetical circulation with the warm air rising across a very steeply sloped front and the cold air sinking. But this is going to be it's like a band of precipitation sets up just north of us. And you can see the temperature structure kind of reflects that, where there's precipitation occurring relatively cool, and the cold air doesn't really come in until you get north of this precipitation band. So it may indicate that there's some clearing just to the north of this.
This is really interesting, Michael. I wonder if there isn't some, interesting step-like structure on the frontal surface itself that allows mesoscale instability to really be more potent back behind the surface intersection of this feature than somewhere else along its topography. Sometimes these fronts are almost step-like. It could be a really interesting case to look at.
Yeah, I haven't looked carefully at cross section through this, but we certainly have the data here if people are interested. By the time we get to the afternoon on Sunday afternoon, this particular model forecast is for some not snow, excuse me, rain. It's gonna be all liquid because the temperatures are around 10 degrees Celsius. But it could be a wet time in the eastern part of our state, southeastern part of our state, and you can see the cold air coming off the lake as the winds turns slightly east.
For that.
So that could just be a miserable day. But the northern part of the state staying pretty decent. And when we get to the end of this, 60 hours in the forecast, that precip again hangs around Milwaukee and Chicago, and we're in this northwesterly flow, a little bit cooler. Actually, we warm up a little bit because where the precip is, it's going to stay wet and cold and close to the dew point, whereas the air temperatures, where I guess things have cleared up a little bit or enough, or dried out, it's not precipitating, no evaporative cooling, you actually warm up. So with northwesterly winds over us. But we have a front just to our south by the time we reach Sunday evening. Just for comparison purposes, if we look at the GFS, and I'll just click through this. Is that showing up, the GFS?
Yeah.
Okay.
Pivotal, yeah.
Pivotal, right. So pivotal GFS. And I'm going to jump to 48 hours just to compare the timing of the front. So at 48 hours, in fact, I'll zoom in so we can see that regionally. Okay, so pivotal actually has us as the precip has the front a little bit through us a little bit earlier, and the precipitation maybe more post-frontal, but the front's a little bit faster. The pivotal forecast, we were northwest winds by the time we get to Sunday morning. Remember, we had those westerly winds over us in the MM5 forecast, and kind of getting breezy and winds out of the north. But you can even see here, this might be the formation of some sort of lake breeze. We can see the winds turning out of the northeast on the along western shores of Lake Michigan. But again, dry. So there's a difference in the forecast here that are going to be obviously going to play a big role in terms of people's perception of how the weekend is, but looks definitely going to be cooler on Sunday. This is Sunday, we're at 45 degrees by 0Z Sunday. 0Z tomorrow, we're expected to be still in the 50s, so a warmer day tomorrow than it will be on Sunday. And if we look ahead beyond this time period, and I want to look at least one other model, it's always good to look at assortment or ensemble of forecasts. By the time we get to Monday morning, the winds are switched back to the west, and so we're going to begin our warm up again. Could be warmer again before that next front begins to come through. West-southwesterly winds warming up. Finally, we'll turn to the NAM and look at the forecast for the northern part of this for our area. I'm going to go back to 48 hours just as our point of comparison. The NAM, interestingly enough, keeps us with a westerly wind at Sunday morning, so the front has yet to go through. It's just about to go through.
Interesting.
Precipitation structure here, not much precip, so this is a pretty dry front. I'll go ahead to 54 hours, so this puts us into around the afternoon. A little weak, I think this is a weak cyclonic circulation that forms just to our southeast, but no precipitation. And if you look at the winds at this point, so really weak cyclonic circulation forms, but you can see that the winds do turn onshore. There's probably a weak lake breeze that sets up. So it's going to be really chilly right along the coastal regions.
Miserable.
That's verified by the temperatures. Look at that. You can see upper
See that?
30s.
It would have posed no problem for me at Miller Park to just close the roof. We'd be watching the ball game.
Right. When baseball returns.
Yeah.
But so yeah, so the weekend right now, I'd say the forecast by sort of the operational models are basically dry. We do have the MM5, which is just running in a quasi-operational mode, is suggesting that we could get some rain showers during the day on Sunday particularly Sunday afternoon. But both the NAM and the MM5 are suggesting a push of cold air off the lake into the eastern part of our state. May not make it as far west as Madison, at least the forecasts don't suggest that. But if you're going to be east of here, or if you're online watching us east of here, from Milwaukee down to Chicago, could be a pretty chilly afternoon on Sunday. But and it could be wet, at least if the MM5 verifies. We can check that out next Friday.
Man.
Finally, just looking at the forecast going into the rest of the week, it looks like a relatively quiet week with some but rapid passages of weather systems. And so I'll go back to the continental U.S. since we have folks from all over the country on today. Really warm in the southern part of the United States. Let's get my favorite map up here, which is just our surface map with precipitation. Again, we're going to have a parade of cyclones along the edge of that cold air along that baroclinic zone toward northwest.
Those
and
are
north.
Alberta Clippers. In January, that's what we call them. They'd be dropping an inch of fluffy snow.
Yeah. As they, you can see a whole stream of them coming from Alberta, going through Manitoba and Saskatchewan, but well to our north. And so we just get small taste of cold air as they pass through. Then we get back into the warm sector. One that goes through late on Monday is going to usher in some chilly air again. Strong cold advection. You can see almost two fronts. Surface front right here, the polar front, maybe an Arctic-like front that's just north of the lakes as this goes by. But that's liquid precipitation, maybe some snow on the shores of Lake Superior. That goes to deepen really nicely. Another high builds in. Again, we get these periodic bursts, warm and cold, warm and cold. Here's the next surge of warm air on Wednesday. And go ahead 24 hours Thursday morning. And we actually stay warm finally.
Yeah, right. Finally, right.
You can see the baroclinicity still to our north. And then we get to Friday, a week from now. Weak cyclone begins to develop on that baroclinic zone before we get perhaps cooler again as that cyclone moves on. So you can see a developing cyclone to our east with a northeast flow for next weekend. So I would say the balance of the week is probably going to be slightly below normal, but that's probably going to put us maybe in the upper 40s to low 50s, so a warmer week than last week. And Pete, I'm going to turn this over to you, but if you wanted to show what normal is and let's look at the progression of temperatures, that might be kind of interesting.
Sure, I can do that. I also was thinking we should probably take a look at the SPC page also, because it sounds like there's a pretty good risk again this week of severe weather a couple of times in the deep south. So
okay, you're going to bring that up.
Yeah, let me get here.
Yeah, we're struggling to really emerge from the late part of winter here, aren't we? Man.
Yeah, it's taking forever. So this, Ed Hopkins in the State Climatology Office puts these maps together and tries to make sure they're updated for us every week for Weather Watch. The red line on here is the daily average maximum if you take the last 30 years of maximum by day and just average them and don't smooth them at all. So this is what the actual maximum temperature looks like. The blue curve is the 30-year minimum going from 1981 to 2010, so the same thing. And then the black lines for each day are the actual observed maximum and min. So you can see we had a couple of reasonably nice days a week or so ago when everybody thought spring is finally here. And now this past week, you can see we had a couple of days where our high temperature was actually about the same as our normal low in the 30s, it looks like, upper 30s. So it's been pretty chilly. If it's felt cold, it hasn't been your imagination.
Man.
Hopefully we'll, so like right now, normal high should be about 60, looks like, right near 60. I think Scott had
I
30
wonder if
year.
there are certain days of the year where it never is the case that the actual high is as cold or colder than the average low. You know, you'd think in the summertime that almost never happens. And maybe there's certain calendar days or strings of days where it never has happened. Scott would know off the top of his head probably, but
Yeah, he probably would.
it really would be interesting to know.
It looks like there's a couple of days back here in, when is that, mid-February, where we had some days like that where the high was below the normal low.
Yeah, I would expect it in the cold season, but I wouldn't expect it
Yeah.
in the warm season. That'd be my hypothesis.
Yeah, could we bring up just a random year from that selection of these sorts of charts, Pete? I mean, I guess it's not really random, but just select any of them. John, I'm going to yell out a year, and we can just bring that one up.
Let's go 1978, heartbreak year for the Red Sox. See what that
All
looks
right,
like.
I got to find those on here.
Oh, sorry, I didn't mean to.
Yeah, no, that's okay. I don't think that's the right page I want to be at.
Looks like really January
Last-
1978, super cold. But that's what Scott says. But yeah, that's right. But I'm wondering about summertime or warm season, April to October. How many times does it happen then?
I don't know.
If you're 2019, and that's not the year we want, but just since that's
I think this is what I want to be at.
Yeah.
Maybe no.
I think click on that. That gets to the cities, and then they might have those maps going back.
Yeah,
There
I
we
never
go.
remember how this goes.
Click on map. Yeah,
There
Oh,
we
there
go.
you
You wanted what, 91?
78.
78.
78.
Yeah, Scott's right. There's some January 10th or so, we had a high of +5, and the average high is like +7.
And
I
look
mean,
at
the
December.
average low is like +7.
Yeah.
Early December, that was pretty cold.
Yeah.
I was going to the winter of 78, 79. I remember the Great Lakes freezing those two winters, 78, 79, and 80. But John's point about having in the warm season the high temperature lower than the normal,
The average low. Yeah.
the average low. At least for this year, we don't see that.
Yeah. Not even close, really.
Looks like in September we get kind of close, or October, but that's not really summer. And then actually mid-July, there are a couple days we had a very small variation in temperature, probably a day we had rainfall.
Yeah.
It's in the middle of this, before you get to the peak,
High of 75-ish. Yeah.
or even
I see that.
65. I think. If you move a little bit more to the right, Pete, a little bit more right there, around that. Oh no, back to. Oh, sorry, left. Right there. Yeah, that one right there. That's a pretty cold day.
Oh, yeah. Okay.
It's not quite as cold as the high, the normal high.
Yeah. There's no way. There's probably a way to do this systematically, and Scott probably is doing it right now. But it would be interesting to know what's the last calendar day of the year where that's ever happened. And then what's the next one that comes up where it happens again, so that you could define some interval where it doesn't happen. And maybe you call that your summer. I don't know. Happened May 11th, 2018. There you go. I told you he'd do it.
Let's take a look at that. 2018.
So May 11th is definitely in the cold season. That's what I would say. That's what I would call the definition. That's the cold season. Oh, it must be this one right there.
Right there.
High of 40.
High of 44.
I wonder if this was
I
it.
don't know which one.
That one right there.
There it is.
He did it within 5 minutes.
Just these guys. That one right there, probably.
We look at the monthly. Okay. Really interesting.
Anyways,
That's the latest. But I wonder if is there anything. Then after that, I wonder what would be the next one that would occur. That's the end of the cold season. But when
right.
Between that date and let's say October 1st, is there another date that we've had a high colder than the average low, or as
Come on,
cold?
Scott. What's the matter with you?
visually, I don't see anything on there during
This year? Yeah.
Yeah, that would be a really interesting way to define the cold season. And then look at what it what it looks like across the country, various, first order stations.
Very neat. Well, thanks. And thank you. Oh, yeah, SPC. We're going to look at SPC just to see the outlook.
Oh, yeah. Sorry to
Can I make
interrupt.
a comment?
Sure,
Yeah,
please.
go ahead.
This is John Young.
Yeah.
Hi, John.
In the summertime, you don't have the huge polar air masses that are coming down even in an anomalous sense. And so it's basically your low temperatures are going to be typically much closer to the normal lows in terms of not being 20 degrees below normal, okay?
Mhm.
And that's what it takes to get your high temperature on a given day lower than the normal minimum temperature. It takes a really major cold air mass to do it, like an anomaly of like 20 degrees. And that's not normally going to happen in the summertime, but it's
Right.
likely to happen in the wintertime.
Yeah, and that even refines my argument for, which I'm kind of making as I go here, that would be a cool way to define the cold season, the bounds of the cold season. The last
Yeah.
day where that's ever happened has to be
Well,
a function of the availability of such an anomalous cold air
Yeah.
mass in proximity to your station.
And the best way to do that would be something that's fairly easy to do, to work on the probabilities of anomalies as a function of season, so that you could actually see that this was a less than 1% event that we were talking about. And you want to know how often that happens. And you can actually then go back to the records and see climatologically what the normal probabilities would go from 1% to 10% chance, et cetera.
Yeah.
So yeah, it's all probabilities
Yeah.
is the way to look at it.
Yeah. That's a good point.
Yeah, very nice.
So we're above normal on precipitation. We're above normal on snow a little bit. And then just getting back to the severe weather, it looks like the probability increases on Sunday and then deep south again.
Oh, he's got a.
Yeah. Kalen said July 27th, 2013 was pretty close.
Okay, I think that's all I got.
Somebody's going to go off and run with that football.
Well, thank you all for participating. Great comments and add additions to the discussion. Again, it's great to see former students and future students joining our discussion. So have a safe weekend. See you next week. Stay well.
Yeah, same here, everybody. Thanks for coming, Pete. Thanks for your help, Michael. Great discussion. John, thanks for showing up and great comment. See everybody next week.
All right.
Okay, bye.